Hello everyone, welcome to our video. I'm Xinjun Zhang from Xi'an Jiaotong University. Today, I'm going to talk about a trial on promoting data-intensive supercomputing through innovation in storage subsystem architecture. With the rapid development of 5G, cloud, AI, and other technologies, massive amounts of data such as videos and pictures have grown exponentially. This has promoted the HPC industry to evolve from the computing-driven paradigm to data-driven paradigm. The mainstream HPC system architecture in top 500 will support data-intensive application well. With frequent data access, the storage system becomes bottleneck in traditional HPC system. We introduced two cases of data-intensive application in our research. A typical data-intensive application is climate research. And complex Earth system model such as E3SM moves to higher resolution, which requires more grid cells to cover the Earth. Outputting all the data from each grid cell, and the model runs can make more input-output performance key issue. During research, we found that climate applications are usually mixed loads. Another case of data-intensive application in our research is the latency HPC log. In the whole process of information analysis, mixed workload and multiple protocols are usually required. Based on the above cases in our research, we found that the following challenges in the data-intensive applications. The first one is multiple protocol interworking and hybrid workload oriented. Another challenge of data-intensive application is that amount of data processed per unit time is getting larger and larger. In conclusion, large-scale, high-performance storage system is required. So, we introduced OceanStor Pacific to our scientific research, which is a next-generation parallel file system. OceanStor Pacific features innovations in unified metadata architecture, processing of large and small OS, and distributed parallel client. OceanStor Pacific optimizes the latency of the overhead in each phase to achieve both high bandwidth and LPS to accelerate our scientific research. Now, we introduce some optimization methods of OceanStor Pacific. Traditional multi-protocol interworking is implemented based on file or object storage. By contrast, OceanStor Pacific introduced a 3-zeros architecture. The file, HDFS, and object protocols are based on a unified unstructured data infrastructure. Without a primary-secondary relationship, those protocols share one copy of metadata and data to leverage the advantages of both file and object protocols. To further improve the parallel access performance, OceanStor Pacific also introduced the Distributed Parallel Client, or DPC. We also cooperated with the Huawei to improve the performance of application software by more than 20% through storage computing collaboration. Another subject we cooperated in is DPU. We are studying the scheduling and offloading of heterogeneous compute power and the feasibility of offloading different operators in order to reduce the data movement and improve the efficiency by offloading some process to DPU. So, the conclusion of my speech is as following. Firstly, HPC industry has evolved from the computing-driven paradigm to data-driven paradigm. Secondly, in our research, we found that the performance of traditional storage system is poor due to a large storage scale. the requirement of high performance and high scalability, and the requirement of the multi-protocol interworking, then we use OceanStor Pacific to accelerate climate research and big data analysis. Finally, we are studying the optimization technology of MPIO at DPC and DPU in cooperation with Huawei to further improve the performance of storage system in HPDA. That's all, and thank you for watching. Have a nice day.